In this video, we'll use the factorial and double factorial expansion coefficients to generate the Taylor-Maclaurin series sum expansion of this Gauss exponential function. It is 2 times square root of 0.5 pi times Gauss of x times e to the power 0.5 x squared. We begin with the expansion, which is the summation of a times x to the power 2n plus 1, where a comes in two forms, the factorial and the double factorial. And the value of n starts from 0 to infinity. So in this case, 16 is good enough. Now we continue with the double factorial expansion coefficient. So array formula, 1 over factorial double, or double factorial, 2 times n plus 1. And we continue with the factorial form. So array formula, 2 raised to the power n times factorial n divided by factorial 2 times n plus 1. Then enter. Their values are exactly the same. Now we can calculate the expansion. So array formula, series sum of the x values raised to the power 2n plus 1. 2n plus 1 starts from at n equals 0. So 1. 2n plus 1 starts from 1. Incremented by, followed by 2 times 1, 3. 2 times 2 plus 1, 5. 2 times 3 plus 1, 7. So 1, 3, 5, 7, 9. So the increment is 2. And the coefficient, you can choose the factorial or the double factorial. We'll choose the double factorial first. And enter. And we'll chart this. Insert chart. And we'll use scatter chart. And show the trend line. So series, trend line, polynomial to the 8th degree. Use the equation as label. In the legend, position at the bottom. So here's the trend line. And here's the polynomial as well, to the 8th degree. Next, we enter the Gauss exponential function. So this is equal to array formula. We start with the Gauss function. Gauss of the x values times exponent of the x values. Then enter. Now we have to show the equation here and the trend line as well. So edit chart, series, trend line, polynomial to the 8th degree. Use the equation as label. And here you have the trend line as well. We'll calculate these polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 8. Now the elements of the matrix. So this is equal to array formula of the x values raised to the power 0 to 8. And we use LINEST to calculate the polynomial regression coefficient. LINEST data y and data x. Then enter. Likewise, the function itself. So LINEST data y and data x. Now that we have done the polynomial regression coefficients, we modify our functions, the Gauss exponential function. So our Gauss x is okay, but our exponent will be 0.5 times x squared. So 0.5 times x squared. So x raised to the power 2. And enter. Now it's getting better. Next, we need to factor in 2 times square root of 0.5 pi. So we start with 2. 2 times. And then after 2 times square root of 0.5 times pi. Close the parenthesis and close the square root and enter. Now they're all in the same trend line. Their data sets are the same. Their polynomial regression coefficients are also the same, and their polynomials are the same. So the coefficient of x to the 0, 0. Coefficient of x, 0.995. Coefficient of x squared, 0. Coefficient of x cubed, 0.361, 0.361. Coefficient of x to the 4th, 0. Coefficient of x to the 5th, 0.0316, 0.0316. Coefficient of x to the 6th, 0. Coefficient of x to the 7th, 0.023, 0.023. Coefficient of x to the 8th, 0. Suppose we use, because we're using the double factorial, we'll change this. We want to use the factorial expansion coefficient. We use this one. Then enter. We still get the same data set. They're the same. They're equal. Their regression coefficients are also the same. The trend lines are the same. The polynomials are also the same. This completes the use of double factorial in generating the Taylor-Maclaurin series-sum expansion of this Gauss exponential function, which is 2 times square root of 0.5 pi times Gauss of x times e to the power 0.5 x squared.